I'm Algebra Annie, and I'm here to help you be successful in your algebra class. Some days you just have to create your own sunshine. Sam Sundquist. Our learning target today is I can factor trinomials of the form ax squared plus bx plus c.
All right, welcome to day 2 of factoring. We're going to do the exact same methods that we learned in our previous lesson. We're just taking another day to practice it. So we're going to factor the problem 3p squared minus 2p minus 5. Our first job is to see, can we make this problem any simpler to use? Can we make the numbers any smaller? So our very first job is to find the GCF of the original problem. So 3p squared, negative 2p, and a negative 5. Prime factorizing 3p squared, I have 3 times p. Negative 2p is a negative 1 times 2 times p. Negative 5 is just a negative 1 times 5. So I'm looking for a GCF. Do any of my lists have anything in common? They do not. So my GCF is a 1, which means this is the smallest that this problem can get, which means we have to work with the original problem. So I'm going to give me a big box so I can put my final answer in. This is the original problem we're working with, so this is the problem I have to find my ABCs on. So I need my A is the 3, I need a B, my B is a negative 2, and I need my C is a negative 5. Once I've found my ABCs, I need to come up with my lists. So I'm coming up with all the ways to multiply together to get me what A times C was. A is a 3, C is a negative 5. So I'm coming up with all the ways to multiply together to give me a negative 5. So thinking it through, the only way to multiply to get a negative is if one of my numbers is negative. So I always start with 1. 1 times what gives me a negative 15? Well, that was a negative 15. Now we said one of the numbers had to be negative. If that's the example when 15 was negative, I need the example when 1 was negative. So there's my 1's. Now I need my 2's. 2 times what gives me 15? I can't think of one. And I check on my calculator. It doesn't have one either. So 2 doesn't work. So 1's, 2 doesn't work. 3. 3 times what gives me 15? Well, that's a negative 5. If that's when the 5 was negative, a negative 3 times a positive 5 will also give me a negative 15. So now I'm going to try my 4's. Use my calculator. 4's doesn't work. Now, if you don't remember how to do it on your calculators, so here's my calculator. We are trying to test the number negative 15. You were trying to see if 4 worked. So if I can divide by 4, that means 4 works. So dividing by 4, I got a decimal, which means 4 does not work. That's how you prove if a number works or not when trying to come up with your lists. So back to our problem. You said 4 didn't work. All right. 1's, 2's, 3's, 4's. Next would be 5's, but those are already right there. So we are now repeating. So our list is done. These are the only ways to multiply together to get a negative 15. Now, of these 4 ways, one of them needs to add up to give me a sum of B. B is negative 2. So we're going to go through these ways, and we're going to see who gives us negative 2. Now, this went with him. He didn't have anything. Okay. 1 and a negative 15 add together to give me a negative 14. Negative 1 and 15 add together to give me 14. 3 and negative 5 add together to give me a negative 2. Negative 3 and 5 add together to give me a positive 2. I'm looking for a negative 2. Here is my negative 2, which means the two numbers that I will be splitting my problem into are these two right here. So the whole purpose of all of this over here was so I knew how to rewrite my term of B so that I had 4 parts. So this is still a 3p squared. I want to rewrite minus 2p. How will I write minus 2p? I'll use the positive 3 and the negative 5. So a positive 3p and a negative 5p, that is the way to rewrite negative 2p. If you combine these like terms, you would have gotten negative 2p. And this is still a minus 5. Now that there are 4 parts, we can factor by grouping, and we know how to do the rest of it from here on out because we did that all last week. So group the first 2 in the first parenthesis. I need a plus sign right here. The last 2 go in the last parenthesis. That is a negative 5. The negative 5 stays inside that parenthesis. This is always a plus sign right here. So now with my first parenthesis, I need to find the GCF. So that was a 3p squared, and that is a 3p. 3p squared, prime factorized, is 3 times p times p. 3p is 3 times p. So looking for my GCF, what do they have in common? I see a 3 in each list, so the 3 comes down to my GCF. I also see a P in each list, so the P comes down into my GCF. So what is my GCF? 3 times P is a 3P. So this is the GCF thought bubble for the first parenthesis. So I'll be taking out my 3P, but I need my leftovers. List 1 had a leftover of a P, so here's my P. List 2 didn't have a leftover. Every single list has to have a leftover. So there is one. We just don't see it. It's because it's a 1. So plus 1. So this was for the first parenthesis. Now I need to do the second parenthesis. I normally like to do it on this side since he's on that side. So I'm going to say over here, negative 5p and a negative 5. Negative 5p is negative 1 times 5 times p. Negative 5 is negative 1 times 5. So looking for a GCF, there's a negative 1 in each list, so he is down here in my GCF instead. There's a 5 in each list, so there's a 5 down there in my GCF instead. Nothing else in common, so my GCF is negative 1 times 5, which is a negative 5. So there's the GCF thought bubble for the last parenthesis. You said negative 5, so I'm pulling out a negative, and now I need to go through my leftovers. So list 1 had a leftover of P, so here's my P. List 2 didn't have any leftovers, but there has to be a leftover here, which means it's a plus 1. So here's my plus 1. Now that I see that my parentheses are the exact same, I'm going to pull that parenthesis out, and whatever was left behind when these two parentheses disappeared is what goes into my other parenthesis. So that is a 3p, and that was a minus 5. So these are what we got. So I've got p plus 1 in the first parenthesis, and a 3p minus 5 in the second parenthesis. Since the first GCF was a 1, there is kind of a little secret hidden 1 right there that we don't really write, but we solved the original problem, so that is our original answer, and you're done. So problem number 4, we're going to factor 15n squared minus 27n minus 6. So first job is always, can we make these numbers smaller to work with? Can we make them easier? So we're going to see if we can factor out a GCF. So I have 15n squared, I have a negative 27n, and I have a negative 6. Do they have anything in common? So 15n squared is 3 times 5 times n times n. Negative 27n is a negative 1 times 3 times 3 times 3 times n. Negative 6 is negative 1 times 2 times 3. So I am looking for a GCF, things they have in common. I see a 3 in each list, so that 3 comes down here in my GCF instead. And I actually don't see anything else. So I'm going to be factoring out a GCF of a 3, which means I have leftovers that I need to find. List 1 had a leftover of 5 times n, which is 5n squared. List 2 had a negative 1 times 3 times 3 times n, so that's a minus n, 9n. And list 3 had a negative 1 times 2, which is a negative 2. Now we are going to factor out this original GCF of 3. And we are going to make sure we don't lose him. He needs to be up here in the final answer. So we're going to make our problem a lot easier by taking out this original 3. We cannot forget about that original 3. And then we're going to find what the rest of the answer is by working with this new baby problem. So this was just trying to make our numbers easier to work with. So now we have a new baby problem that we're going to solve. He was 5n squared minus 9n minus 2. This is the new baby problem we're going to solve. When we find the answer to the baby problem, we need to make sure that we put the baby's answer with the 3 that we factored out to get the original answer. So new baby problem, I need my a's, which is 5, my b, which is a negative 9, and I need my c, which is a, and my c is a negative 2. So now I need to come up with my lists. I'm trying to find all the ways to multiply together to get what a times c is. A is a 5, c is a negative 2. 5 times negative 2 is a negative 10. So I need to come up with all the ways to multiply together to give me a negative 10. Now the only way to multiply and get a negative is if one of your numbers was negative. So start with 1. 1 times what is a negative 10? 1 times a negative 10 is a negative 10. So if that was the 10 being negative, I need the example when the 1 was negative. So there's my 1s. Now I need my 2s. 2 times negative 5. Well, if that was the negative 5, now I need the 2 to be negative. 1s, 2s, 3s don't work. 4s don't work. 5 is a repeat right there, so that's the end of my list. Now of all these ways, somebody needs to give me the sum of b, which you said was negative 9. So we need to go through and see what all of these would actually add up to. 1 and a negative 10 add up to a negative 9. Negative 1 and 10 add up to 9. 2 and negative 5 add up to negative 3. Negative 2 and 5 add up to 3. I was looking for negative 9. So here's my negative 9, which means the two numbers that we are trying to split our b up into are that positive 1 and this negative 10. So all of this side work over here is so I could split up my b. So that is still a 5n squared. I'm going to rewrite negative 9n as a positive 1 and a negative 10. So here's my positive 1n, because we're dealing with n's, and now a negative 10n, because we're dealing with n's. This is how I chose to rewrite negative 9n, and that's still a minus 2. Now that I have 4 parts, I can group. The first two get grouped into the first parenthesis. I have to have a plus sign. And these last two get grouped into the last parenthesis. Since that was a negative 10, this is still written as a negative 10. Now that I have them grouped, I need to find the GCF of each parenthesis. So the GCF of the left parenthesis, prime factorizing 5n squared and a 1n. 5n squared is 5 times n times n. 1n is 1 times n. So trying to find my GCF, I see that they have an n in common in each list, and there's nothing else, so my GCF's n. So this is the thought bubble for this parenthesis. I'm taking out the n, which means I have leftovers. List 1 had a leftover of a 5 times n, so here's my 5n. List 2 had a leftover of a 1, so here's plus 1. I did it for the first parenthesis. Now I need to do it to the second parenthesis. So my GCF of the negative 10n and the negative 2. So negative 1 times 2 times 5 times n. Prime factorizing negative 2 is a negative 1 times 2. Looking for a GCF, there's a negative 1 in each list, and there's also a 2 in each list. Nothing else in common. So my GCF is a negative 2. So here's the thought bubble for this parenthesis. You said minus 2. So here's me minusing 2. Now I need leftovers. List 1 had 5 times n, so this is a 5n. List 2 didn't have anything. It's because it's hidden. Every single list has to have a leftover. So that meant it was a plus 1. Now I see that these parentheses are the exact same. So here's me pulling out the exact same. We're going to have leftovers when these disappear. So that's my n minus 2. Now these are the answers to the baby. The baby was not our original problem, which means we need to make sure that we come back up here and we add our baby's answer to the original with the 3 in it. And this is your final answer, and we are done.
What did we learn today? I can factor trinomials of the form ax squared plus bx plus c. And I look forward to seeing you tomorrow in class.